Good morning, afternoon, or evening. Welcome back to Mr. Morrow's algebra class. How y'all doing today? Today we're going to talk about one of my favorite subjects. It's graphing linear equations. I love it. It's fun. I think you guys are going to have a good time with it and learn a lot. Today we're going to be talking about graphing equations with two variables. So the two variables we're going to be working with are x and y. We're talking about linear equations, okay? And a linear equation is an equation where x has a power of 1. Okay, that means the exponent has a power of 1. It's invisible. If the x has a different power other than 1, then it is not linear. A linear equation or function produces a straight line. If you're graphing a linear equation or function and your line is not straight, then you made an error. When we're talking about a linear function, we're talking about the most basic here is y equals x. Okay? Y equals x. A little bit more convoluted, we're talking about y equals mx plus b. We'll talk about that a little bit later. Not today. That's called the slope-intercept method. But this is basically what we're working with. When we're talking about linear equations, okay, we're talking about a y equals an x equation. X has a power of 1, y has a power of 1, and you're going to have a straight line. Now, there are several methods for graphing linear equations. We're going to talk about two of those methods today. And the first one is the easiest of all. It's the table method. And the table method, we already learned this. You simply create an x and y table, which we have already done, and choose values for x. Those are your independent variables. Then evaluate the function for the values of x that you have chosen. I like to use the Morrow 5. Which are nice, easy numbers. -2, -1, 0, 1, and 2. Then after you've found your x and y coordinates, graph the ordered pairs and draw your line. Remember, they must be straight. Now, when I tell you to graph y equals 2x minus 5, something like this, remember that the first thing you always have to make sure you do, always, is solve for y. Okay? I want to solve for y. In this particular case, y is already by itself. It has been solved for. So I have y equals 2x minus 5. Let's go ahead and plug in my Morrow 5 here as the x values. Then I'm going to get my y values. Remember that the y depends on the x. The x is independent. So when x is -2, 2 times -2 is -4 minus 5 is -9. 2 times -1 is -2 minus 5 is -7. Sorry about that. 2 times 0 is 0 times minus 5 is -5. 2 times 1 is 2 minus 5 is -3. 2 times 2 is 4 minus 5 is -1. Remember, all I'm doing is just plugging it in. So again, when x is 2, 2 times 2 minus 5, that's how I get my -1. All right, so now I have my points. So I've got -2, -9. So that's -2, -9 is right here. Got -1, -7. 0, negative. Oh, wait a second. Something's wrong here. 0, -5. That's because I messed up here. Sorry, guys. Let's start from the beginning. -2, -9. Sorry about that. -1, -7. Sorry, I was not paying attention. Sorry about that. And again, -1, -7 is over here. Okay, come on, Mr. Morrow. 0, -5. It's right here. 1, -3. And 2, -1. Go ahead and make a straight line going right through these points. And there you go. There's your line. Nice and easy. All right, let's check out another one. Another method is using what's called the standard form. The standard form is in the form of a times x plus b times y equals c, where a and b are coefficients. Okay? Sometimes you will be asked to convert a linear equation into standard form. Simply manipulate the equation so as to put the x and y together on one side. You want to isolate the constant in this case. Now, what are they talking about? Let's say I tell you y, say I tell you that y, I don't know why this is not working, y equals 2x plus 5, okay? When they want you to write this in standard form, they want you to get the x and the y's together. So you're going to subtract 2x to both sides, and you're going to have negative 2x plus y equals 5. Now this is in standard form. In this case, the constant is what you want to have all by itself on one side. Now, the usefulness of the standard form is when you want to graph using the x and y intercepts. Think about the word intercept. When a missile intercepts its target, that means it hits its target. Okay? When you intercepted a highway, that means you hit the highway. You went into the highway. So an interception is kind of like an intersection. And the x-intercept is basically the x comma 0 ordered pair. It is the x value on the x-axis when y equals 0. To find the y-intercept, that is the 0 comma y ordered pair. It is the y value on the y-axis when x is 0. So let's see how this works. First of all, when they tell you to graph something like this, negative 4y plus 2x equals 12, what I always look for is the following. I isolate the c, the constant, and I look at the a, which is the number being multiplied to x, and I look at the b, which is the number being multiplied to y. If the a and the b are factors of the c, go ahead and use the intercept method to graph. Again, if the a and the b are factors of c, go ahead and use the following intercept method to graph. Okay, so 4 and 2 are definitely factors of 12, so I can and will use the x and y intercept method to graph. How do I do this? Well, all right. I got negative 4y plus 2x equals 12. First thing I'm going to do is find the x-intercept. The x-intercept is the x value when y is 0. So I'm going to make y 0, and I'm going to solve for x. Well, 4 times 0 is 0, so I've got 2x equals 12, divide by 2, x equals 6. So my y-intercept point is 6, comma 0. That is my y-intercept, and that is my x-intercept. That is the x value on the x-axis when y is 0. Let's go ahead now in red over here on the left side. Let's do the y-intercept. The y-intercept is the y value on the y-axis when x is 0. So I have negative 4y plus 2 times 0 equals 12. 2 times 0 is 0. So I have negative 4y equals 12. Divide by negative 4. Y equals negative 3. So my y-intercept is 0, comma negative 3. It's the y value on the y-axis when x is 0. And now, let's go ahead and plot these points and graph. So I have 0, negative 3. It's my y-intercept on the y-axis. And I have 6, 0. That's my x value on the x-axis when y is 0. Go ahead and connect the dots to the best of your ability, and you have just graphed this line using the intercept method. And you use the intercept method using the standard form of a linear equation, which again is ax plus by equals c. All right, so those are the two methods that we are going to practice now today. Hope this is making sense. One thing before we move on to some practice, let's talk about graphing vertical and horizontal lines. Okay? First of all, vertical and horizontal. Let's see how we can remember this. Remember that horizontal, okay, remember that horizontal is like the horizon. Think about going to the beach or even a large lake, and you look at the horizon. The horizon is going this way. Okay, that's the horizon, left to right. Vertical is the opposite. It's going up and down like a column. Okay, so horizontal is flat, left to right, and that's the x-axis, and vertical is going up and down. That's the y-axis. All right, so let's talk about vertical and horizontal lines. The equation of vertical line is in the form of x equals a, where a is any real number. The vertical line goes through the x-axis. So when you have an x equals equation, it is going to give you a vertical line. It is going to go through the x-axis. If you notice, when you have an x equals a equation, there is no y. So you don't even have to worry about the y-axis. It is just a value that is going through the x-axis. It is a vertical line. The equation of a horizontal line here, this is wrong, this is a typo. The equation of a horizontal line, please make this change, is in the form of y equals a, where a is any real number. The horizontal line goes through the y-axis. Best way to learn this is just to look at an example. X equals -2. I'm not dealing with the y at all. I just want to make sure that this line is going through the x equals -2 value. So this line goes vertically through the x equals 2. Y equals 4. Okay, I'm not dealing with the x at all. I'm only dealing with the y. So y equals 4 is going through the y-axis at y equals 4. There it is. That's my 4. Okay, and this is -2. That's how you graph horizontal and or vertical lines. Again, an x equals equation is going to give you a vertical line. A y equals equation is going to give you a horizontal line. All right, let's continue. Graph each linear function. Go ahead and use the two methods that we have today to graph each depending on how they give it to you and what works. First of all, let's look at number 1. When I have y equals 3x plus 1. All right, y has already been solved for, so let's go ahead and make a little table. Let's use my moral 5, -2, -1, 0, 1, and 2. When x is -2, -6 plus 1 is -5. When x is -1, -3 plus 1 is -2. When x is 0, y is 1. When x is 1, y is 4. And when x is 2, y is 7. Go ahead and plot those points. -2, -5. It's right here. -1, -2. 0, 1. 1, 4. And 2, 7. Connect the dots in a nice straight line. And you have graphed an equation. Number 2. I got 5x minus 3y equals -15. Okay, wait a second. This is in standard form. If you wanted to, you could solve for y. And I would solve for y if the a and b are not factors of 15. But 5 is a factor of 15 and so is -3. So I'm going to use the x and y-intercept method here. My x-intercept is the x value when y is 0. So I've got 5x minus 3 times 0 equals -15. -3 times 0 cancels out. Divide by 5. So I have x is going to equal -3. So I have x equals -3 when y is 0. Let's find the y-intercept. The y-intercept is going to render me 5 times 0, because it's the y value when x is 0, equals -15. That cancels out. I divide by -3. Y equals 5. Okay, so my y-intercept is 0, 5. That is the y value when x is 0. So let's plot the x and y-intercepts. The x-intercept is -3, 0. The y-intercept is 0, 5. Bam. Connect the dots. You just graphed a line using standard form x and y-intercept method. Awesome. Awesome. Next. Okay, y equals negative 0.2x plus 3. If they ever give you a decimal in front of the x, go ahead and turn it into a fraction. Okay, that's going to be the easiest way to do this, I promise you. So this really is going to turn into y equals negative 1/5 x plus 3, because 0.2 is 1/5. Go ahead and use your table method to graph this. Now, remember what I had said in our last session when we first talked about making tables? You always want to use the moral 5 unless you have a denominator in front of the x. If you have a denominator as a coefficient, okay, you have a fraction as a coefficient, you want to choose x values that are multiples of the denominator. So, in this example, I would use negative 5, 0, 5, negative 10, and 10. Those are all going to be multiples of the denominator, and they are going to eliminate the denominator. Let's see how it works. Negative 1/5 times negative 5, that's going to be positive 1. Positive 1 plus 3 is 4. When x is 0, negative 1/5 times 0 is 0, plus 3 is 3. Negative 1/5 times 5 is negative 1 plus 3 is 2. Negative 1/5 times negative 10 is going to be positive 2. I'm sorry, positive 2 plus 3. Sorry about that. Positive 2 plus 3 is 5. And when x is 10, you've got negative 2 plus 3, which is 1. All right, let's see how this works. Go ahead and let's graph it. Let's graph these points. All right, let me see. My graph is not going to fit here, so let me drop it down here, guys. Sorry about that. All right, so I've got negative 5, 4. I've got 0, 3. I've got 5, 2. I've got negative 10, 5. And I've got 10, 1. Connect the dots. Put arrows on both sides, and you're done. Okay? Now, one thing that I haven't been mentioning, when you are graphing, I should have mentioned this, always label your x and your y-axis. That way the reader knows where the axes are, and they can read the graph a lot easier. Sorry, I haven't mentioned that before. Hey, next. Got y equals 3/5 x minus 2. All right, I already have it solved for y. The coefficient of x is a fraction, so I don't have to convert that. Let's make our table and rock and roll. Remember, I've got a denominator here, so again, I'm going to use multiples of 5 as my x. I want to use multiples of the denominator. So again, I'm going to use negative 5, 0, 5, negative 10, and 10. When x is negative 5, we've got negative 3 minus 2, which is negative 5. When x is 0, we've got negative 2. When x is 5, we've got 3 minus 2, which is 1. When x is negative 10, we've got negative 6 minus 2, which is negative 8. And when x is 10, we've got 6 minus 2, which is 4. So let's plot the points and graph it. Negative 5, negative 5. It's negative 5, negative 5. 0, negative 2. 5, 1. Negative 10, negative 8. And 10, 4. Connect the dots. You got your graph. Label the x and the y-axis. Done. How about this one? How do you graph y equals negative 2? Remember, that's a y equals equation. Okay, y equals equation, we're not dealing with the x-axis at all. So y equals negative 2 is simply going to go through the y equals negative 2 value forever. Label your x and y axis, very important in this one. Because if you don't label your x and y axis, we don't know what you're graphing. X equals 3. Again, think about it. There's no y there, so it's never going to go through the y-axis. It's an x equals 3 equation. It's never going to go through the y-axis. So x equals 3 is simply going to go through the x-axis, where x equals 3. It's a vertical line. Make sure you put your x and your y-axis. Label it. And you're done. Hope that makes sense. All right, let's do a few more. Okay, let's graph y equals negative 2/3 x plus 5. Again, I've got a fraction as a coefficient, so I'm going to choose x values that are multiples of the denominator. So xy, this time I'm going to use 3, negative 3, 0, 6, and negative 6. Okay, when x is 3, we got negative 2 plus 5, which is 3. When x is negative 3, we got 2 plus 5, which is 7. When x is 0, we've got 5. When x is 6, you got negative 4 plus 5, which is 1. When x is negative 6, you've got 12 divided by 3 is 4 plus 5 is 9. Okay, so 3, 3. Negative 3, 7. 0, 5. 6, 1. And negative 6, 9. Connect the dots. You've graphed your line. Label your x and y axis. Number 8, 3y plus 5x equals negative 12. Okay, temptations. Oh, I'll use the x-intercept and y-intercept method. Well, no, not really, guys. What happens here is, yes, 3 is a factor of negative 12, but 5 is not. So you're going to have a fraction, and it's extremely difficult, almost impossible to accurately graph a fraction by hand. So we're going to have to actually solve for y here. So I've got 3y plus 5x equals negative 12. Subtract 5x to both sides. 3y equals negative 5x minus 12. Divide by 3. Y equals, remember that this 3 gets divided to the negative 5x and the negative 12. So I've got negative 5/3 x. Leave it as a fraction, even if it's improper, minus 4. Now I can make a little table. Let's make a table of values. I have a denominator of 3 in the coefficient in front of x, so I'm going to use multiples of 3. So 3, negative 3, 0, 6, and negative 6. When x is 3, you got negative 4 minus 4, which is negative 9. When x is negative 3, you got 5 minus 4, which is 1. When x is 0, y is negative 4. When x is 6, that's negative 30, negative 10, that's negative 14. And when x is negative 6, you got 10 minus 4, so that's going to be 6. So 3, negative 9. Let me go ahead and move this up a little bit. Move you guys down so you can see what's going on. Okay, first off, remember to label your x and your y-axis. So I've got 3, negative 9. 3, negative 9 is right here. Negative 3, 1. It's right there. 0, negative 4. 6, negative 14. That's going to go off our graph, so we can ignore that one. And then we got negative 6, 6. And there you go. You need at least 3 to 4 points. So if one of them goes off your graph, that's okay. And that was a pretty poor line. Let's try to see if I can make a better line there. There we go. That's much better. All right. Got to be neat. All right. There you go. Now, what if I give you these two equations and I say, write a linear equation represented by the graphs below? So for A, I have this vertical line First of all, here's my x-axis, here's my y-axis. I have this vertical line going through the x-axis and only the x-axis. So this should be a x equals 1, 2, 3, 4, 5, negative 6. That's the equation. How about b? B, you have, first of all, this is my x-axis, that's my y-axis. Very important to label axes. And you have this horizontal line going through the y-axis. So this is a y equals equation. Very good. So this is y equals negative 1, 2, 3, 4, negative 5. And there you go. Hope you guys learned a lot. Hope you enjoyed it. Thank you very much. Have a wonderful day. Take care. Bye-bye.